Lunar ladies, and this is Mini Challenge 1.
We will be taking this bin of flour and putting cocoa powder on top and then throw rocks at it to experiment and look at ejecta and rays.
I threw a rock at an angle and the ejecta went in the opposite direction.
After studying Vesta's crater formation, we simulated the snowman shape of the craters and how we think they were formed.
Here is our snowman. We took rocks and we dropped them into the flour and cocoa powder, which created these craters. Here is some of the ejecta from the crater, and you can see they created rays.
We believe that the order of the Vesta snowman craters occurred from smallest to biggest. The largest crater overlaps the medium one, and the medium overlaps the small. In addition, there is ejecta in the small crater from the other two impacts.
Our last crater experiment is a liquid version of our other tests. We dropped food dye into a bowl of water and studied the way it splashed up to simulate how a central peak forms and then collapses. With this, we conclude our crater experiments. We now know the ejecta's distance correlates with the rock size. Both the surface area and force generated gets higher for larger objects.
Also for Mini Challenge 1, we studied the angle of repose. The angle of repose is the angle that materials form when poured into a pile. We tested 3 materials.
The steepest angle was from the material garden soil, and then after that it was sand, and then following was vermiculite.
So what are you ladies looking for?
The angle of repose.
Great. What materials you got?
Dirt.
Did we measure to get the angle of repose, we also discussed how weathering affected our materials. We simulated Earth's crust moving by slightly shaking the plates with our piles of sand, garden soil, and vermiculite. When shaken, the materials settle.
We also studied the meteor crater near Winslow, Arizona. Impact craters on the Earth don't last nearly as long as those on asteroids or the Moon. On Earth, wind, water, and vegetation will quickly erase craters. Even the largest ones are eventually destroyed by plate tectonics. However, on asteroids, the only weathering is caused by later impacts and the solar wind.
That's all for Checkpoint Challenge 1. Thanks for watching!